Let's look at the Google Lighthouse web performance tool and the image scores that you get in there. And I'll let Jon walk us through some of the analysis we've done about how to improve your scores in Lighthouse, particularly as it pertains to image scores.
Yeah, so Lighthouse is one of the tools, performance testing tools that has gained popularity last year or so. We mentioned also webpagetest.org, which is probably one of the oldest, but still one of the most useful tools for testing and analyzing performance out there there is. But yeah, Google obviously has included a metric of performance. How fast and responsive the site is in their index. So if you have a slow site, your search engine rankings will also be worse, and the opposite. So and this is sort of built around how Lighthouse works. So that's why Lighthouse is gaining part of the reason why Lighthouse is gaining popularity. One of the things the Lighthouse tool is looking at is images, and how optimizing images in certain ways will make the performance of the website better. And this slide we're looking at now, it suggests that this particular site should size the images correctly. In this case, I guess the images have been a little bit too big in terms of pixels, and then use efficient file formats, and so on and so on. So and these milliseconds often, but in this case there's actually more than a second to save. They add up, and of course one can address this manually, but there are, if you switch to the next slide now, Ken, there are 3 or 4 different strategies you can choose in order to address image optimization and making sure that your images are optimized well. The first option here is how the images are when they come out of your favorite tool for editing images. Of course, you can do a lot of optimization and tweaking and tuning from Photoshop, like we have an example of here. But in this experiment, on the next couple of slides, we use this as sort of the baseline. This is how the image is by its own, when no optimization and no tweaking has been done. So you can also think of it as a JPEG coming straight out of your camera or something like this. And then the second strategy might be to use some sort of automated task runner, or have some processes optimizing your images while you're building your website. Grunt is one of these task managers or task runners, which can loop through all the images in your web project that you're developing, and optimize these images, and maybe even convert them to different formats and sizes, so you can put them together with your responsive image tags, for instance. But all this is happening built on when you're actually programming the website. So it doesn't make use of any information available, coming with the HTTP request and so on. But option 3 does make use of that. So the way that runtime optimization differs from build time optimization is that runtime optimization can take input from the HTTP request for the images, and do some limited but still optimization that can't be done offline or build time. The best example might be to analyze the HTTP request and looking for WebP support, and then convert the image to WebP. This can be done in many different ways. Usually among the companies offering runtime optimization, this is done through some sort of regular expression on the user agent string or other less scalable ways. But also through client hints, which is slowly but steadily evolving into a standard. Client hints enable dynamic resizing of the images, but this has to be done runtime on a server capable of performing these kinds of actions. Yeah, fourth option is where it still happens runtime, but you have more and reliable information about the requesting device. You don't have to do dirty tricks like user agent sniffing or regular expressions and things on the HTTP header. You can look up in the device database like WRFL and get all the information you need from there before you optimize the image and return it. So if you switch to the next slide, it's important to understand the difference between runtime optimization and the device-aware optimization. With runtime optimization, you definitely get a lot of information out from the HTTP requests, which you can use to optimize the image. But then again, it requires a lot of maintenance. And this is sort of the core of the WRFL offering and the WRFL API and the WRFL database to let Central Mobile handle the maintenance and make sure the data is up to date and all the logical operations in the API is working and up to date. So that's the whole purpose, that you can actually trust that the WRFL API is doing the device detection correctly. While if you're using regular expressions on certain HTTP headers fields like the user agent string, you have to constantly monitor and maintain this expression in order not to get false positives or even broken images. But still, runtime optimization without device detection, it works. If we compare to the baseline, you can switch to the next slide now again. If we compare to the baseline, which in this case is 100%, the runtime optimization is 60% of the original baseline. So 40% less data if you look at the HTTP information in the request and use whatever you can there to optimize the image, whether it's to resize with the help from client hints or convert to WebP from other HTTP header fields. So it's definitely a good thing. But then it will only get you so far. It's difficult to find the right size of the image. In many cases, the images are on the web today. They're too big. You rarely find an image which is small or smaller than it should be, and this is difficult to detect without proper device detection. With WRFL, you get the size of the screen, for instance, both in terms of physical pixels with the resolution of the screen, but also the recommended maximum size of the image in CSS pixels, if you will, or display pixels. And thanks to this extra information that device detection brings you in Image Engine, we're able to reduce the traffic, the image payload down to 34.5% of the original, which is huge. And this is roughly half the traffic compared to the runtime optimization as well. And this, of course, affects the load time of the web page. It's going to be a faster page load. with all the good things that comes from that. And it's also going to be lower operational costs if you're on a CDN charged by gigabytes transferred and things like this, for instance.
Right. So, just to clarify a couple of things, the Wurfel device detection that we refer to, it's built into Image Engine. So it's although we've kind of highlighted that device awareness, it's important to, seems to automatically go on. It's important to point out that not only do we get that device awareness, but it's seamlessly integrated into the image optimization process, and it also is put out there on the edge servers for a content delivery network, so to make this all seamless.
Yeah, that's great.
Okay. Great. Now, a point of clarification also. So, how does this relate to image or responsive images? So, the kind of the build time optimization might include responsive images, but how does something like Image Engine relate to the responsive images approach?
Yeah, it's a easy question with a long answer, I guess you could say. But with build-time optimization, you have to be a developer. You're developing making the HTML and making all the image tags and defining your breakpoints, and how many different derivatives of the same image, different sizes and versions and formats of things you need from the same image in order to fit your breakpoints, the number of breakpoints you have. So it's going to be the image tag will be long. It will be multiple lines, maybe 10, 15, 20 lines long, and then you also need maybe 5, 10 different images, and this you need to create. Either manually or through a task runner, like we mentioned, and this will, it will definitely work. It will the browser will pick the right image depending on your breakpoint, or at least the closest image. There will rarely be a 100% fit, but at least it's a step in the right direction. But it's going to be also a maintenance issue there, because once a new device or a new screen or something enters the market and you figure out that you need a new image format or a new size of the image, you would need to go back in time sort of to recreate this specific breakpoint of the images. But with Image Engine, you can reduce the number of lines basically that the developer has to create in the image tag down to 1 or 2 lines, and let Image Engine handle the format conversion and even the resizing of the image. So it's it's basically dividing the work in two. Whatever can be automated, Image Engine does, and then the developer can focus on the design of the web page, and then make sure that the Image Engine can do its job by converting and optimizing the image according to the current situation, the current devices on the market.
Great. So if anybody's interested, you can start a free trial for Image Engine at imageengine.io. Just contact us, and you can see the impact it has on your Lighthouse scores.